Hi. Thank you. Good afternoon, distinguished guests, and welcome to this Plenary Session 5. I'm Wei Han, and I'll be your moderator for this session. It's my pleasure to be joined by three distinguished speakers. First up, I would like to invite Dr. Wong Wai Kin. He's an independent electrical and power engineering consultant with over 30 years of experience in Asia Pacific, having held senior leadership roles in Australian transmission, market operators, and even developers. Next, I would like to invite Mr. Jian-Ming Chang. He's EDF's Director for New Markets Development in APAC, having led the market entry into Australia and now doing the same for Southeast Asia. And last but by no means least is Mr. Jonathan Khan, who is the co-founder and managing director of ERS Energy, leading RE solutions provider in the region, and one of the early pioneers of solar in Malaysia. So today, as the world pivots towards sustainable green energy sources, there's been a market shift in energy generation. We've moved from traditional, controlled, stable, predictable fossil fuel generators to a complex combination of more unpredictable, uncontrollable renewable energy technologies, most of which are extremely capex heavy and have near zero marginal cost of generation. So, as ASEAN nations continue its RE transition and push towards achieving its RE targets, what are the key enablers and considerations for nations to ensure a sustainable and successful transition? And in particular, how important is the appropriate infrastructure in enabling this transition? And can the ASEAN power grid we've heard so much about this morning be the key to fulfilling all three aspects of the energy trilemma? Please, Dr. Wong.
Okay. Firstly, before I begin, I'd like to thank Gamuda for organizing the session and for inviting myself to share my perspectives. And also want to thank the organizers of the conference as well as distinguished guests who have basically stayed back until this late session to hear what we have to say. Now, what I want to do is to just frame the scope of this session by sharing my perspectives. Now, myself, I've worked about now coming to 2 decades of integrating renewable energy in Australia. And I've actually participated in various roles, which includes power system planning, power system operation, project development, as well as looking at issues both at the transmission and distribution level and also delivering the next generation of enabling technologies to achieve reliable and secure high renewable integration. Now, much of my work has been undertaken in Australia, and I believe some of you would recognize that Australia is often seen as one of the leading case studies for renewable integration at both transmission, utility scale, as well as in the distributed, or now we call it consumer energy resources. Some of the benchmarks you may be aware. Now, Australia as a nation currently is about 40% renewable by annual energy, but there are some jurisdictions in Australia which achieve something like 80% renewable penetration by annual energy, which suggests that there are now frequent market intervals where renewable penetration hits 100%. Some of you may be aware of those reports put out by the market operator. And so what I've been working on the past decade is to look at what does the power system need in terms of the next generation of solutions at scale to ensure we maintain supply reliability and power system security while keeping costs and economics viable. And I think this is important because at the end of the day, for example, as system planners, we can specify requirements for our grid, but however, if industry and the private sector cannot deliver, or the supply chain cannot deliver on the solutions you need at scale, in volume, in a timely manner, then you cannot achieve the required renewable penetration while maintaining system reliability and security. So I'd like to paint now this focus on this session because the previous session also talked about renewable energy integration, but primarily from a utility perspective. So hopefully we can complement that excellent discussion in that session by looking at what do we need from technology integrators, technology providers, the private sector developers, as well as broader supply chain considerations. So if you allow me just to therefore define what are all the main buckets of consideration. Now, you have probably heard this being covered, but I'll present it in a slightly different way, and particularly flavored by my previous experiences working in the Australian power system and energy market. Now, firstly, technical fundamentals. When we talk about future and new renewable capacity, often we are specifically referring to solar and wind resources, which are power electronics defined by software. Okay, this is different. Of course, there's also hydro and nuclear, right? But those technologies are primarily still based on synchronous generation, and so they maintain the current power system security philosophy. So therefore, you don't need to change the way you plan and operate your power system if you are looking at hydro or even nuclear. But if you are looking at wind and solar, these are power electronics. The characteristics are entirely defined by software. And this is a very different technical characteristic compared to synchronous machines. Synchronous machines essentially deliver a broad range of grid stabilization services like frequency control, voltage control, short circuit current or fault level contribution as part of the package, right? All you need to do specify is the megawatt capacity. Ensure you have the gas or the coal or whatever fuel to keep the plant running, and you will get grid stability sort of inherently as part of the package. Not so with wind and solar. Wind and solar largely provide energy, and the current generation of wind and solar inverter-based generation largely still does not provide the same level of ancillary services necessary to maintain system security. Now, frequency control to some extent are being resolved. In fact, the previous presentation touched on grid forming inverters or grid forming batteries. And the first grid forming battery was deployed in Australia in 2018. So that's 7 years ago now. And in fact, now every new battery development in Australia is grid forming. And we are quite close to now what would be seen as a standard for grid forming battery requirements in Australia. So that is the positive aspect. But however, when it comes to other services, for example, system strength, in particular short circuit current contribution. Now, inverter-based resources largely cannot provide that function economically. Now, it is possible for you to over-provision inverter capacity, but the experience in most jurisdictions shows that such a project or such a configuration is not economic, is not viable. To invest in a lot of inverter capability that's only used for a few hundred milliseconds per disturbance. So I think the reality here we need to accept is that it's not just about the technical requirements of maintaining or integrating renewables, very much is often the cost and also supply chain. One comment I want to make is regarding some of the alternate technologies. Now, in Australia right now, we maintain grid system strength and fault level primarily now through deployment of synchronous condensers. So some of you may be aware, for example, in New South Wales, the transmission network service provider Transgrid has now made a decision that synchronous condensers, rather than grid-forming batteries, are the only dependable option for system strength. And so they have specified that they will invest in at least 20 synchronous condensers going forward. Now, one of the issues we are now finding is that the order book for synchronous condensers is at least 5 years in advance. So if you order a synchronous condenser today, it will not be delivered before 2030. So in the meantime, what do you do then if you have an emerging grid stability issue over the next 3 years? That's a bit of a predicament. And so this is some of the considerations on the supply chain, in particular costs and timelines that you need to consider. Now, the other aspect is a fundamental shift in the economics of a VRE-based grid. Now, the good thing, but also a challenge with wind and solar, essentially, wind and sunshine is free, so there's no fuel cost. So in other words, there is a zero short-run marginal cost, which is often touted as an advantage. However, most of our electricity spot markets, the pricing is indexed or referenced against really the short-run marginal cost of dispatch, right? So we have seen in jurisdictions, therefore, with high VRE, wind and solar, that therefore your spot price goes to zero. And that reflects the zero or near zero short-run marginal cost of wind and solar. Now that is a significant disruption to the revenue model and therefore the business case for certainly legacy plant. And this is the factor that has triggered the premature mothballing of fossil fuel generation in Australia, because they just can't compete with zero marginal cost generation, short-run marginal cost generation, and they are also relatively inflexible, right? Steam turbines, for example, typically need 4 to 6 hours, turn up or turn down. And so that inflexibility means that the only solution is to mothball or retire, because you just can't run economically. And so, and not to mention lastly, the point is that solar and wind investments are very heavy on CapEx, which means that now the methodology for modeling the economic viability has to be made on the entire life cycle of the asset, which means you have to make some very significant assumptions about what is your revenue model and what is the if it's an electricity market, what that market will behave like over the entire, example, 20-year life of a battery. So this is very different from existing fossil fuel, gas and coal generation, because a significant component of your cost is fuel costs. And you can still continually manage that through hedging contracts for your gas and coal supply. But you can't do that for wind and solar. There's no cost to hedge against future wind and solar pricing because the cost is zero. All right, so therefore, when we do even technical power system planning, we need to therefore consider also the economic and commercial side of the equation, because that is what enables the planned capacity to be delivered. Otherwise, we'll have no capacity delivered, which is a predicament that AEMO has flagged in its latest electricity statement of opportunities report, where AEMO qualified that Australia's ability to meet the 43% emissions reduction target is now contingent on the timely commissioning of new VRE capacity. And these are the factors which are now actually causing delays. We are observing that in projects.
Okay, thank you, Dr. Wong, for that very insightful explanation about grid planning. Maybe to hear from Jonathan and Jianming, the developer and EPC perspective, how important really is understanding the infrastructure availability and expansion roadmaps to investing and promoting the RE industry?
Maybe I can start first. So thanks, Wei Han. And Dr. Wong, I can certainly relate to all the challenges that they faced in Australia, which is also causing a fair bit of frustration also. I think there are a lot of valuable lessons that you can actually extract. And to look at the market that we are in, here's an example. There were a lot of talks around systems planning, coordinated planning. I think at the end of the day, what we're trying to do is to drive best value for consumer. If you are able to coordinate a transmission network build out to connect to places where there are wind and solar resources, which fundamentally doesn't have any connections anyway, that is effectively what Energy Co is doing in New South Wales, just to kind of go back to the example of what Dr. Wong is saying. And in that particular case, giving the right guarantees, having the right coordination allows to drive investors' confidence as well. And that is important because from an EDF perspective, for those of you who don't know, we are EDF Power Solutions. It is a subsidiary of EDF Group. or probably better known as the nuclear producer of the world, 100% owned by the French state. In my opinion, I think that renewables for transition is already a mature technology, but that I'll leave it to Jonathan to address further. But I feel that you solve one problem, but you create another, which is what Dr. Wong has been suggesting a lot in terms of grid instability. Hence, what is the solution behind this? My personal experience in Australia is that I've looked at every single data room of pump hydro acquisition in Australia. I think the reality here that we have to understand is that pump hydro, with all due respect, is not building solar or wind. It is an asset class that requires long gestation, long lead items that has been discussed as well. So if you kind of categorically split these two up together, what we have to understand here is that the system planning part plays an important role. And in that particular case, what then makes sense? We have looked at, as mentioned, all the data room. We have actually rejected more advanced projects just because the design weren't right, just because the contractors weren't right. Because going for the more advanced project on paper doesn't mean that it can be delivered. Failing to get delivered means that you won't have the right system to integrate all these variable renewables to ensure what the topic was, which is a just, smooth transition towards renewable energy.
Okay, thanks, Jiaming and Dr. Wong. So to add on to that, I think what the key enablers are for us to have a successful RE transition, I think, again, just to re-emphasize grid infrastructure and capacity, there is a data point that 80% of delayed renewable energy projects in the world globally is because of grid connection issues. So I think having the grid there is an investment that needs to be made. Like we were chatting earlier, that you need to build the highway first before you put the vehicles on the road. So I think grid infrastructure is the key component. Of course, then I think governments, and especially in ASEAN, if we could get together and do more technical and regional grid coordination, I think would significantly allow us to have a better renewable energy transition, because there is also if we were to have ASEAN as a single grid connected entity, we would be the 4th largest electricity consumer in the world. So I think there is a lot of positive and benefits that we can come together and build a very strong grid in ASEAN that is powered mostly by renewables.
Thank you, Jianming and Jonathan. So having heard the importance or the gravitas of having robust grid infrastructure and clear guidance for system expansion, what are some key lessons that ASEAN or Malaysia even could perhaps take from other more developed countries in expanding their grid infrastructure, in building out their RE industry and roadmap?
All right, some of the lessons learned. I think at the moment, now Australia is at a stage where the existing grid infrastructure can no longer provide sufficient hosting capacity for the amount of RE that Australia needs to take it beyond the current 40%. And so you may have heard of some of the major transmission augmentation projects. Now, one of the projects I was involved in the early stages was the project Energy Connect, which is an interconnector between South Australia and New South Wales. That one is an interesting case study because originally that interconnector is meant to cost a total of Australian 1.9 billion and was supposed to be operational by 2023. So unfortunately now the cost on that project has now increased to 4.1 billion, more than double, and has now, the latest commissioning date has been pushed back to end 2026, potentially early 2027. So one of the learnings now we see is that now the RE uptake in Australia is now challenged because of the speed that we can deliver the necessary transmission upgrades. Now, what are some of the factors here? I think one of the general issues that as a nation that Australia is now struggling with is productivity. So this is economic-wide. It's not just about the power industry, but it's certainly manifesting itself in terms of increased costs and delays in power projects. And so I think one of the lessons that ASEAN can take from, at least from Australia's recent experience in transmission projects. Firstly, is make sure that you get the cost part right. Cost control is essential. And in the course of project delivery, your project governance and project control is very, very important. That's the first aspect here. Another aspect we also found is in some sectors, for example, in pump hydro. Now, pump hydro, the last major projects in Australia were completed in the early 1980s. And until the latest project, which is Snowy 2.0, I'm sure some of you have heard of that. That means 40 years have passed since the last projects were delivered. And so what's happened is that generation of expertise, the engineers from the original Snowy projects have now retired and left the industry. And so when Australia tried to resume its development in hydro, we found that we actually lack the right experiences and skill sets because they no longer exist. And that is one of the reasons, I believe, why we are seeing the issues that Snowy 2.0 is experiencing right now. There are a number of other issues actually, but we won't go into that in too detail. So the lesson therefore here for ASEAN is that to ensure the upskilling, the human resource, both in terms of the appropriate skills they need, as well as to make sure the quantities are available to drive your transmission or grid infrastructure upgrades. Now, what is fit for purpose? Now, there's no single answer to that. Every country will have its own unique power grid configuration. You have your own unique socio-economic context, and you will, of course, have different fuel resources. Some countries will be richer, or most countries will be richer in solar, but some may have additionally access to viable wind as well as hydro. And so therefore, you need to make the call, therefore, on the right technologies of which you will need capacity in terms of the manpower and the skills that you need in order to ensure that this is actually part of that supply chain issue. The supply chain is not just about equipment, it's not just about transmission infrastructure, but on the people, the human resource needed to deliver on those upgrades and therefore the energy transition.
Thank you, Dr. Wong. And maybe Jianming and John, given your international exposure, what are some good lessons you have learned from international markets in promoting RE growth and making sure that the growth in RE ties together with the build-out of infrastructure?
Maybe I can go ahead first on this also. I think we have all recognized that transmission is always consistently the problem. And in fact, it is now being put in such a situation where we are facing knee-jerk reactions where people don't want to inject high capacity, or rather low capacity factor generation into the grid. And they are forcing, on one side, the supply side, to build batteries to increase the capacity factor. And on the other side, the high load demand customers are also being forced and turned away from the grid because they are consuming so much power that they are draining capacity from the grid that could potentially cause blackout. So now you have two different sides of equation. On the demand side, people are going to build microgrids on their own. On the supply side, people are trying to co-locate solar plus battery. I'm not saying that's a bad thing, but that's the status of reality. But when you start to propagate all this, is that really the best use of system? Or actually, we can say that we can actually have a little bit more foresight to plan a little bit more of a long duration storage, and the world that we live in, this part of the world, it's just not much wind. It's a lot of solar, so it's not difficult to kind of time the duration of storage you need to shift. So with all this system planning and proper planning in place, actually you can drive a lot more investors' confidence without having the curtailment and guarantee some dispatch, and even drive the load center on the other side.
Yep. Well, for me, with the Ares Energy, we've done utility scale projects in Malaysia, Philippines, Vietnam, and now starting in Australia. So some of the lessons we've learned, Dr. Wong has covered Australia, fair enough, but I think in the Philippines, we do get speed in terms of approvals to deploy utility scale projects. But the grid planning side, we have to work with NGCP, and we do see some pros and cons as compared to Australia, where in Australia you do take at least 12 to 24 months to develop a project just for grid approval. whereas in the Philippines you can get it in 6 months. So what I see from an EPC point of view in this part of the world is that we need to balance speed with stability. This is where I need to commend Malaysia, the government, Energy Commission and TMB. We've been doing it slow and steady, rolling out renewable energy, making sure we have the right talent pool to do it. And I think there needs to be a good lesson, because when we went to Vietnam, we did the fit out together with the rest of them, 3 gigawatts in 2018. And during COVID, there was between 30 to 50% curtailment. So again, great readiness. One of the other lessons we could learn is in Europe. I think Denmark, as Dato CRO from TMB just now was saying, relationships. Denmark used its neighbors as a battery storage. They linked up their grid with Norway and the other European countries so that they would stabilize their renewable energy penetration into their own grid together with their neighbors, and they would share. And I think this could be a good direction for ASEAN to work towards.
Thank you, John. And I think following on from that, what would be the impact of poor system planning or not ensuring the appropriate infrastructure is in place before the RE industry grows its installed capacity? And can the ASEAN Power Grid be a solution to that?
Yeah, so I think on the topic of power system planning, I think the challenge here is you have to relook at what fitness for purpose power system planning really means when you are dealing with integrating RE where the technology is still evolving. So as we've seen again the example that inverter-based resources are now moving from the previous dependence or dominance of grid-following generation to now increasingly looking at grid-forming technology to try to backfill some of the grid stability services that were the deficit that has emerged as you retire legacy synchronous generation. Now, this means that now the fitness for purpose in power system planning is not a function of just your understanding of your transmission network. It now is closely coupled to the availability of the technology that will deliver the next generation of grid reliability and stability services that you will need in order to maintain your supply reliability and security. Now, this means that power system planners now cannot work in isolation. You have to work very closely with the generation and also the network support technology providers and developers. This is another category. So grid-forming batteries is a very good example of that, because the initial grid-forming batteries, in fact, at this point, there are no universal global standard on what is a grid-forming battery, what are the functionality required, right? Unlike, for example, a gas turbine synchronous generator, you can buy one from almost any OE that will be compliant to any grid code that currently exists. Not so, for example, for grid-forming inverters. And so the challenge here for power system planner is that now you really need to engage the technology supply chain ultimately to see what are the options available today, what are the options that are going to be available in the next near term, 5 years, but more importantly, are they available in the right scale or quantity, given that most jurisdictions are planning to integrate gigawatts of solar and wind over the next 5 or 10 years. So there is therefore this, in summary, fit-for-purpose system planning now has to be a lot more holistic. You need to consider all aspects of the grid and not just the transmission poles and distribution poles and wires, but certainly on the generation side as well, to the degree that perhaps it never needed to consider under the previous planning approach.
Thank you, Dr. Wong. And maybe, John, I think you touched earlier on capacity, curtailment, and I think Jianming as well. Maybe it's a developer's perspective on the potential impacts of poor infrastructure planning.
Yeah, sure, I'll take it first. Yeah, so I think just quickly on this would be, yeah, if we don't invest in the grid early, we would have a lot of stranded assets. So I think it's critical that these come in, as I mentioned earlier, on fitting out too fast, too quickly, and then you'll have curtailment on these plants. So it isn't just about cables at the end of the day for this. It's also about confidence, contracts, and stability of the grid. So I think we must invest in it.
I like the example that Jonathan gave earlier about Denmark relying on Norway. And another quote that I'll give of Steve Jobs, that you can sometimes only connect the dots looking backwards. And in this particular case, EDF in France did not build pump hydro to service the excess solar that comes out of Spain from day one. It actually built pump hydro to service all the nuclear power plant fleets that it has for safety purposes and reasons. And now it becomes such an incredible asset for us to balance the entire system in Europe, because they share the same fiscal system. And back to our region here, more often than not, you have some hydro assets out in Sarawak or in Laos. You have a lot of solar in this region. How do we connect? I think it's about the baby steps for us to take. And once we get there, and you need obviously experienced infrastructure developer, us inclusive, among others, people who are capable of building it, to be able to deliver those assets on time. And I think that's one of the most important things that we all share today.
Yeah, maybe if I can jump in again here, Wei Han, because I just want to add another aspect on the power system planning, what kind of, call it, a reform or improvements we need. Now, power system planners generally do their work in order to comply with the regulation of the grid code. Most national grid codes include requirements for power system security and reliability embedded in the grid code. And so I need to highlight now that, again, with the rapid evolution of generation technology in the inverter generation space, the grid code need to keep pace with the change. And so therefore, there need to be a kind of a quick and efficient grid code review process to ensure that the grid codes remain current. Now, just to give you an example, when I started in Australia nearly 20 years ago, you probably get a new version of the grid code, or we call the Australian National Electricity Rules, probably one new version every year. But today, for the last, I would say, 7 to 8 years, we get a new version every month. Every month, there's a new version. The original Australian grid code was about 300 pages. Now it's about 3,000 pages. Okay? This is an example of how quickly your grid code needs to change, to adapt, to keep pace with the changes, not just in technology, but in your market and your generation mix. And secondly, it's also an indication of how complex the requirements have become, that now your grid code has become 10 times as long, essentially. So the message here I'd like to convey, therefore, is more to the regulators, that the regulators now also need to ensure that their process are basically also fit for purpose, particularly to keep up with a fast-evolving power system and fast-evolving technology development that's going on, especially in inverter-based generation.
Thank you, Dr. Wong. It sounds like there's a lot of coordination which is required for this Asian power grid to work. Maybe in the interest of time, what would be the one key takeaway you would want to, provide the audience for this session?
Yep, sorry, can you repeat the question, Wei Han, because of the echo? Yeah.
Just as in the interest of time, to close off the session, what would be one key takeaway you would like to give the audience for this session?
Yeah, I think probably the one key takeaway is that now, whilst there are now a number of case study examples that countries in ASEAN can reference, and there are ample examples, I've been talking about Australia, but I also need to add there are plenty of learnings from Europe, from jurisdictions like Germany, Northern Ireland, Great Britain, particularly in offshore wind, for example, even in the United States that you can reference. However, ultimately, you have your own country, your own unique technical, social, economic context. And definitely, therefore, you cannot just take a cut and paste approach, but what you need to do is really to take the building block learnings from other jurisdictions, but create your own very unique solution, your own very unique recipe to attain the economic and sustainable renewable integration, including any interconnection between the countries. So I think, in other words, own your own journey, define your own journey, because it will be uniquely yourself, but do draw on the general learnings from elsewhere internationally.
Final 2 points is really just to echo Dr. Wong's point is, while there are a lot of learnings that we can take internationally, the key point is there's no need to reinvent the wheel if we don't have to. And last but not least, within the region, we are not European Union. We are trying, I mean, even Australia itself is very fragmented in its own rights. In this region, it's about building trust, starting one of the first projects, and that really starts to unlock a lot more potential.
Yeah, so for me, is I guess renewable energy in ASEAN, I think if we get it right, it's not just about renewable energy, but it's actually about regional prosperity for everybody.
Thank you very much. Maybe any questions from the audience? If not, we'll close the session. Yeah, thank you.
Thank you so much, Dr. Wong, Jianming, Jonathan, as well as our moderator for this panel, Wei Han. That was very engaging indeed.